We're going to do a couple problems in section 3.2. So we're going to start with 32. And this is similar to the problem we did with the paper in the class. Similar, but not the same. So we got a box with a square base, and no top is made from a square piece of cardboard. So I'm going to start with a square piece of cardboard. And the word square tells me already that the sides are all the same length. And we're going to cut 4-inch squares out of each corner. So this is 4 inches by 4 inches, 4 inches by 4 inches, 4 by 4, and 4 by 4. And we're going to fold then, presumably on the dotted line here, and dotted line here, dotted line here, and dotted line here. Fold up each of the flaps to make a box. The box needs to hold 2,700 inches cubed. And they want to know, how big is the piece of cardboard? Well, that means I need to know the dimensions. How big is it? X on this side and X on that side, because it is a square. So the volume of a box, if I fold this up, it's going to have a height of 4. It's going to have a width of X minus 4 and minus another 4, so X minus 8. And it's going to have a length of X minus 4 and minus 4, folding it up this way. And so I'm going to get X minus 8 again, and that's got to equal 2,700 cubic inches. So to solve this, we're going to divide by 4, and we're going to get X minus 8 squared equals, let's see, goes into 28, 6. That'd be 24, so it leaves 300. 4 into 30 is 75. I believe that's what we get, 675 inches. And the 4 was in inches, so this reduces it to inches squared. This was 4 inches, so that reduces the units to inches squared. Then I'll take the square root, and I get X minus 8 equals the square root of 675. And the square root of inches is an inch. And this is going to be plus or minus. Most likely we're going to have to use the plus one because minus sides wouldn't make much sense here. But before we decide that, we'll add the 8. And so X is going to have to be 8 plus or minus the square root of 675 inches. Now the square root of 625 is 25. So this is more than 25. I believe it's about 26. So 8 plus 26 would make 34. And 8 minus 26 would be a negative answer, so that's not going to be it. So it's going to be the answer 8 plus the square root of 675 inches, both dimensions of the box. Okay, 33. Now we're dealing with a farmer who's trying to make pens, a couple of pens like this. And they have a 500 feet of fencing. So the 500 feet has got to make all the sides and that middle divider. What are the dimensions that maximize the area? Well, if I want to find the dimensions, I'm going to have to use variables. Now, it appears from this that these are all going to be the same length, so I'm going to call those X. And looks like these are all going to be the same length, so we're going to call them y's. It doesn't look to me like this has to be equal to that. But since these are rectangular pens, those three would have to be the same. These two would have to be the same, and presumably those would have to be the same. I'm making a little bit of assumption there and going with it. So, that 500 feet of fencing has to cover 3 x's, and it has to do all 4 y lengths. And the area of this these pens would be equal to length times width. That would be this times this gives me the area of that. And I want this to be as large as possible. Well, if I try to graph this, it's going to be a little confusing because I've got 3 unknowns, the area amount and the length and width. But this constrains what the relationship between x and y. So just so I'm solving for x, let's say, to start with, I'm going to solve for y in this and then replace this y with what I get. So 500 equals 3x plus 4y. If I'm solving for y, I'm going to subtract 3x from both sides. And then I'm going to divide by 4 both sides. And then I'm going to replace the y in the area formula with 2 times this times x. Now let's clean this up a little bit. So 2 times this is going to reduce this to a 2. So 2 divided into 500 is 250. And 2 into negative 3x is negative 1.5x. I know you guys like decimals, so I'll put it that way. Times x. And if I multiply the x through, I get 250x minus 1.5x squared. Well, this looks like it's an upside down parabola. And so it's going to go like this, and so I need to find the maximum area. And it happens at, according to the quadratic formula, at minus b over 2a is the x that would give me the maximum area. Well, see, minus b, that would be minus the opposite of b, that would be negative 250 over 2 times a. That would be negative 3. So 250 divided by 3, I believe, is 83 1/3. So this piece of fence would have to be 83 1/3 feet, and so would this one and this one. So I'm going to use up 83 1/3 3 times. So let's see how much is left for my y's. So 83 1/3 times 3 is going to be 250 feet. Well, if I use 250 feet for these, I have 250 feet for those. So 250 divided by 4 will tell me what y is, which is what I would do if I did this. I would take 3 times my 83 1/3, subtract it from 500. 500 minus 250 is 250 divided by 4. That'll tell me how big each y is. And so divided by 2 is 125. Half of that is 62.5 feet, or 62.5 feet. So y's are 62.5 and x's are 83 1/3. And I have all the dimensions of my enclosed pen.